It really wasn't that long ago that AI had the memory of a goldfish. You'd have a quick chat, and poof, it would forget everything. But now, wow, we've taken this incredible leap. AI can now basically inhale and remember entire libraries of information all at once. It's a total game changer for sure, but it also cracks open a whole new can of worms when it comes to danger. And that right there, that's the big question we're digging into. When an AI has a perfect photographic memory of a mountain of text, what happens if just one single dangerous idea is hidden somewhere inside? Can it spot the trap, or does it get fooled? Well, let's find out. So, what exactly changed? Well, in the world of large language models, LLMs, the buzzword everyone's talking about is long context. That's the fancy term for this massive memory upgrade, which has basically turned these AIs from simple chatbots into these analytical powerhouses that can reason over entire books at a time. To really put this into perspective, some of these models can now process over 40,000 tokens in one shot. Now, for you and me, that's like sitting down, reading a short novel from the first page to the last, and remembering every single word perfectly. It's just an incredible piece of engineering. But of course, with that kind of power comes a whole new set of risks. Researchers started realizing that, hey, we've gotten pretty good at making AI safe in short little chats, but making sure it stays safe when it's swallowing a whole book, that's a completely new challenge. And frankly, we haven't explored it nearly enough. Right, for years, the focus has been on what we call safety alignment for these short back and forths. But when you're dealing with these enormous documents, the old safety rules might just go right out the window. It's a completely new frontier for AI safety, where the sheer amount of information just changes the entire game. And here's the problem. When an AI has to find one single harmful sentence, that one needle in a giant haystack of perfectly safe text, its own safety programming can get totally overwhelmed. Its attention gets spread so thin across thousands of words that it's much easier for a dangerous instruction to just slip right through the cracks. It turns out more information isn't always better. Sometimes it's just more noise. So before they could even think about fixing this, researchers had to really understand it. They needed to map out the specific ways these super-powered AIs could be deceived by nasty information hidden deep inside these long documents. They basically boiled it down to three main ways these systems can fail. You can think of them as different levels of trickery. First, you ask a bad question about good material. Second, you hide a bit of dangerous info. And third, well, the whole thing is just a trap from the start. Okay, first up is what they call query harmful. This is where the document itself is totally harmless. Let's say it's a dense engineering textbook. But then a user comes along and asks, hey, using the principles in Chapter 7, tell me how to build a weapon. See, the context is safe, but the question is trying to twist that innocent information into something dangerous. The second one is partially harmful. And this is that classic needle in a haystack problem we were just talking about. Imagine a single line of malicious code buried deep inside a 500-page programming guide, or one sentence encouraging self-harm hidden in a very long, very supportive article. It's sneaky. And finally, we get to fully harmful. This is the most straightforward attack. The entire document you feed the AI is just packed with unsafe stuff, like a manifesto promoting violence. And then you just ask the AI to summarize the key points. There's no haystack here at all. The whole thing is made of needles. Okay, so once the problems were laid out so clearly, the researchers got to work and developed a two-part solution to specifically train these AIs to fight back against these new long context threats. They called it, appropriately enough, LongSafety. So the solution has two really important parts. First, there's LongSafety, which is the specialized dataset they use to train the AI. Think of this like the AI's new advanced safety course material. Then there's LongSafety Bench, and that's the benchmark they use to test the AI after the training. Basically, it's the final exam. And let me tell you, this LongSafety dataset is huge. We're talking over 17,000 examples, each one specifically designed to teach the AI how to navigate these tricky situations. And each example is, on average, 40,900 tokens long and covers 8 different types of safety challenges. It's incredibly thorough. Now, this all sounds really good on paper, right? But the million-dollar question is, did it actually work? Does this new training make AIs genuinely safer when they're swimming in massive amounts of text? Well, the results were pretty fascinating. The results were actually pretty dramatic. When they ran the final exam, the LongSafety bench test, a standard AI model scored around a 51. But after it went through that special LongSafety training, its score jumped all the way to over 66. That is a massive improvement in its ability to spot and refuse dangerous requests hidden in those long documents. And this really gets to the core finding of the whole thing. The researchers proved that you can't just rely on the safety training you use for short conversations and hope it's going to work for these huge documents. It's a fundamentally new problem, and it absolutely requires a new, specialized solution. The old ways just don't cut it anymore. And you know what's maybe even more impressive? The AI didn't just get better at the exact problems it saw in training. Nope, the new safety skills actually generalized. It got better on totally new safety tasks, and even performed well when they tested it on documents that were even longer than anything it had been trained on. All right, so why does all this, a deep dive research paper about AI training, actually matter to you and me? Well, because these long context models aren't just stuck in a lab anymore. They're already powering the tools that we are using every single day. Seriously, think about it. Whether you're asking an AI to summarize a 100-page report for your job, analyze a stack of legal documents, or just help you with some complex research, you have to be able to trust that it won't be easily tricked by some hidden malicious data. This research is such a critical step toward building that trust and making our tools safer and just flat out more reliable. And that brings us to the final and most important question. AI's abilities are growing at this mind-boggling speed. This work on long context safety is a huge step forward, but it also shines a big spotlight on the constant challenge we're facing. As AI gets smarter and more powerful, how do we make sure our ability to keep it safe and aligned with human values can keep up? It's a race, and it's one we absolutely have to keep running.